scene, what we done mostly was to finalize a sort of a new version of the iCub. It was being designed, so it was under design for maybe 18 months. It's called version 2 point something.
The current version of iCub, which is iCub 2. We started it in around mid-2010, let's say May 2010, and the design took quite a lot, let's say a couple of years more or less. So spent in the development of the expressive phase for Grenoble University in France.
We're gonna have a battery, so this is a mock-up just to simulate the weight, which is just gonna snug fit inside it. And so the iCub is gonna be autonomous, available like for walking. Plus, we are looking into adding Wi-Fi capability to the robot done like through the years. So the first robot was born naked, and then we added the cover, and then we add the skin onto the cover. The new robot is gonna start directly with the skin, so we're looking into different ways to integrate the skin.
White spots in between black ink, pages thin, so you can fill lots of them.
So in my group we are trying to address the problem of whole body motion control, so trying to understand how to coordinate all the degrees of freedom of the robot, including the legs, in order to balance, plus doing multiple tasks.
So I work in the Codigo project. The aim of which is to control the robot in relation to the forces exerted on the environment.
To begin with for walking and balancing.
Identification of the parameters that affect the dynamics.
Design of a new component actuator. Its main feature is the possibility of varying the stiffness of the joint.
They are really biologically inspired. So I started to work a little bit on the visual attention on the robot. So the robot right now is able to attend to salient objects, features in the environment, auditory attention as well.
So for next year, we are thinking about having the first demo of the robot fully force controlled, able to exploit multiple contacts on his own body. Like when I'm sitting on the chair, I'm having my hands on the handles, I have my legs on the chair, and also I'm not just using the feet to balance my own weight, but I'm using multiple contacts. And we are trying to exploit the iCub skin plus the iCub force torque sensors in order to get this behavior in the iCub robot.
iCub 3, which is the new version of the iCub, whose main features are it's going to be slightly taller.
Taller is going to give us more room and more space to add more sensor and actuators inside, but also is going to be taller because in order to perform action in the real world, we figured that like 1 meter robot is like too much as a toddler to be able to reach over a table, for instance.
We're also looking next year at using new materials for the iCub. So we have a couple of ideas of using plastic in certain places. Try to see if we can get a cheaper robot. At this point it's very, very expensive. So we need to certainly lower the cost, explore objects just by using touch, maintaining grasp, evaluating the quality of grasp from tactile information and so self, so giving the robot the ability to understand the body in space and make sure it doesn't do crazy stuff, like it doesn't crash on furniture, it doesn't hurt people and so far. So having this tactile visual understanding of space, basically space around the robot, walking and using vision to guide walking in space, in an environment. So those are three new projects that we'll be developing, and together with, of course, what is already going on. So we're still working on object recognition and on action recognition for the iCub. So these are two basic skills that we like to make as reliable as possible.
Christmas Mubarak.
Buon Natale a tutti. Buon Natale.
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 Buon Natale!
Buon Natale.
Buon Natale.
Buon Natale e felice anno nuovo.
Buon Natale e felice anno nuovo!